All right, we're going to talk about circles. We're going to talk about area and circumference, and we're going to talk about arc length and sector area. So first of all, a circle, typically we talk about how big it is, either using its radius or its diameter. If its radius is 5, its diameter is the distance all the way across, or twice that amount. So in this case, it would be 10. We use pi to figure out the area and circumference, and the reason we do this is because pi is a relationship specifically for the diameter. If I take the diameter, I can fit 1, 2, 3 diameters and a little bit more, and this is where pi comes from. It's the little bit more. So in this case, my circumference is 10 times 3.14, or about 3. So if I multiply it times 3.14, that'd be 31.4. Okay, that would be how far it is around that thing. It's roughly 31.4 units or inches or whatever I'm measuring in. If I want to give the exact number, I could say it's actually 10 pi. 31.4 is an estimate. And if I want to give a really rough estimate, instead of using 3.14, I could just use 3. And then I can say, well, it's 30. It's a little bit more than 30. Similarly, pi helps us figure out the area, which is how many little squares fit in this thing, if I could actually count squares that fit in that thing. And so I just take the radius and I square it. So in this case, the area is 25 pi. We typically put the pi second. If I wanted to put in 3.14, I think that's, here, I got my calculator here, 3.14 times 25. It's equal to 78.5. That is an estimate. This is the exact number. This is an estimate, but it's very close. And finally, if I wanted to, I could just do it times 3. 75 plus a little bit more would be an approximation. Okay, so, I noticed right here, I have this arc right here. There's an arc from here to here. And I'm going to change colors. A section of a circle is known as a sector. And so this right here is a sector, and this looks like it's about 90 degrees. Let's just say it is 90 degrees. And we can figure out the area of that sector, as well as we can figure out what the length of that arc is, which is what we're going to do. So that's easy enough. It's 1/4. I mean, if that's 90 degrees, it's 1/4 of the circle. It's pretty easy. I could find 1/4 of both those things. But sometimes you don't get an exact number. So let's do it with that as an example. And then later, when we've got weird numbers like 55 degrees and so forth, it'll be much easier. So the way we'd figure out the either one of them is we'd say, well, if this is 90 degrees, we've got our part over our whole. We want to set up a proportion. So I have 90 over 360 is one side of my proportion. And the other side of my proportion is, I don't know that part. So the sector is the part. So I don't know what that is. I'm going to call it X. And my whole is the area that I'm talking about. If I'm trying to find the sector area, so area is everything. So that portion is that. And I can use any of my numbers. I'm going to use my 25 pi first. So if I do 25 pi, that is it. All right, so I can cross multiply and solve here. So I'm going to multiply those two. So I got 90 times 25 pi. I've got X and 360. Now this is not the only way to do it. And then I'm going to leave this as pi. I'm going to figure out what 90 times 25 is on my calculator over here. It's 2250. That equals 360x. I divide by 360. And I get 25/4 on my calculator. It reduces it for me. Pi is equal to x. So that's the exact amount. I could plug in 3 for that. I could plug in 3.1 for that, depending on that. But it's literally 25/4 pi is the exact amount of that, in the same way that 25 pi was the area of the whole thing. Similarly, if I wanted to do it for circumference, same idea. It's 90 over 360 equals, I'm looking for the part, which I'm going to change pen colors again. I'm looking for just the arc length. Okay, the arc length is just, so the entire thing is about 30 plus around. So this is going to be about 1/4 of that, or I can do that in my head. It's going to be about 7.5, between 7.5 and 9, I think. Okay, so the whole circumference, let's do it with 31.4. This will work either way. I could also do it with the 10 pi, and I'm looking for the, I'm going to call it the sector length, because literally this thing I could put a string on there and stretch it out. So if I cross multiply, I get 90 times 31.4 equals L, and I'm going to do a trick here. I know I'm initially going to multiply by the 360, but then I'm going to divide again, so I'm just going to divide right now. I'm going to save myself a step. So in this case, I get 90 times 31.4 divided by 360, and I get 157/20 on my calculator, because these things, you know, they write it this way. But then I was like, well, I want the decimal number, so I got to hit my old SD button here. And that's, oh, 7.85. My 7.5 was super close. Okay? 7.85 is my length of that right there, which I don't even have space for here. So the arc length is 7.85. In the same way, my sector area, and that would be in units because we're measuring distance, versus my other one, I did 25 fourths pi. Two different ways to write answers, and that would be in units squared. Okay, I'm going to do one more. All right, so let's pretend, once again, I've got a circle, and I've got a, maybe this is 6, okay, my radius. And maybe I have a, let's say, 130-degree arc here, or sector. The sector is the area, it's the piece of pizza, basically, whereas the arc length is here. So I always have to figure out my hole first. I have to figure out both my area and my circumference first. So my area of this thing is going to be 36 pi units squared. And my circumference is going to be 12 pi units. And so once again, roughly this 36 around it, and a little bit more than that, and then basically 36 times 3 is around 120. It's a little bit doing that in my head. Okay, these are the exact numbers. I could plug in 3.14 or 3 if I wanted a really rough estimate. So once again, I am looking for the circumference as well as the area. I'm going to do circumference first. Let me do, this is about 1/3 of the circle. So I'm going to guess, well, 1/3 of 12 is 4. It's going to be about 4 pi. Or once again, if I use 3, it's going to be about 12 in total. So 1/30 is my part over my whole. So 1/30 over 360 degrees. That's going to be my fractional part. And my whole circumference is 12 pi. And this is, I'm going to call this L because it's the length of that string that I wrap around that part of the circle. And then I'm going to cross multiply. 130 times 12 pi equals L times 360. And when I do my my 130 times 12, it's going to be 1560 pi equals L over 360. And then I'm going to divide both sides by 360. And I'm going to get 13/3 because my calculator is super nice and reduces for me. If I wasn't able to do that, I might have to reduce this manually myself. Okay, so my length of that arc is 13/3 pi. Or if I plug in 3.14, I'm going to multiply this times 3.14. That happens to be about 13. I was really close with my estimate. 13.6 is what that rounds to. This is the exact, this is an approximation because I'm using 3.14. All right, same thing. If I want to find the area, I'm going to switch between colors one last time. I'm almost done. I'm trying to find out the area of this. The area of this whole thing is 36 times pi, or about 120. So once again, I'm going to do 130 times over 360 equals my area divided by, let's see, my whole area is 36 pi. Okay, I'm going to do another trick. What you might notice is ultimately, this is just, these two numbers are going to stay over there. I can really figure this out by just saying, well, this is my fraction of the total. I can do it all in one step here. So 130 times 36 divided by 360 is 13. Wow, that worked out perfectly. Pi equals x. Oh, that totally made it. Is that right? I guess it is. All right, ciao.